Okay, the next way to solve a quadratic is to solve it using the quadratic formula. Now, the good thing about this quadratic formula is there's no ifs, ands, buts about it. There's one way to solve it, and I'm going to solve it by the quadratic formula. So factoring, I had to go through, okay, is it this way? Is it this way? Oh, I'm not sure. What do I do? In the quadratic formula, it works every time. I set it equal to 0, plug it into the formula, boom, there's my answer. Okay, now, the only reason that this way is a little bit more difficult is I have to think back to when we were in chapter 1.4 and we were simplifying those complex numbers. I might have to do some kind of simplifying here, but it's the least amount of thought is involved here because I'm just plugging into a formula. Okay, so let's look at an example. Let's say that we have x squared plus 5x minus 11 equals 0. Okay. So in this case, I'm already set equal to 0. Great. First thing I'm going to do now, since I'm set equal to 0, is I'm going to find what my a, my b, and my c is. So my a is going to be the number in front of the x squared. If there's no number there, it's a 1. The b is the number that's in front of the x, a 5. The c is the constant, or the number that does not have a variable. So that's going to be negative 11. Once I've identified the a, b, and c, now I'm going to go plug into the formula. So my formula is going to be the opposite of b. So I'm going to use a negative 5 this time. Plus or minus the square root of b squared. And I'm always going to put these in parentheses so that my calculator does not mess me up, because it will. Minus 4 times a times c all over 2a. Okay, now when we go to simplify, think back to chapter 1.4. We dealt with the square root first, so we're going to do the same thing here. So the first thing that I'm going to do is I'm going to simplify underneath that square root. So I've got 5 squared, which is 25. 4 times 1 is 4. 4 times 11 is 44. So I've got 25 plus 44. So I'm going to get 69 all over 2. Well, because 2 times 1 is just 2. All right, so now that I've simplified that square root, I need to make sure that it doesn't need to be simplified anymore. So the square root of 69 has no perfect squares. It cannot be simplified. So that's as far as I can go. All right, so I can leave this answer exactly the way it is because that square root is already simplified. If it's not, then I would need to do a little bit more. So let's see another one where we might need to do some work here. So let's say we've got 2x squared plus 4x equals 11. All right, let's look at one more. First thing I'm going to do, I need to set this one equal to 0. So I need to move that 11 to the other side. So I'm going to have 2x squared plus 4x minus 11 equals 0. Now I can find my a, b, and c. So my a is going to be that 2, b is going to be 4, c is going to be negative 11. Be careful, I have to make sure that I'm now using the negative 11 as that c. Now I can go to my formula. I'm going to say opposite of b. So I have a negative 4 plus or minus the square root of b squared, always in parentheses, minus 4 times a times c all over 2a. Okay. So again, we're going to simplify what's underneath that square root first. So that's going to give me 104 underneath there. All right. Now, 104 though, I need to look at that because that does get simplified. So I'm going to take that square root of 104. Let's see what we have here. So that can be 4 times 26. 4 is 2 times 2. So I'm going to end up with 2 square roots of 26. So I'm going to replace that. I'm going to have negative 4 plus or minus 2 square roots of 26 over 4. So the last thing that I might be able to do is simplify, which I actually can in this case, because 4, 2, and 4 can all reduce. So I'll be left with negative 2 plus or minus the square root of 26 over 2. That would be my solution. So don't forget, whenever we do this, that we need to make sure that that square root gets simplified, and then if we can reduce, that we reduce.